This is 3.3 markup markdowns. Okay, so first we're going to look at markups. Let's pretend that you are a video game maker and you sell me a video game for $20. Now, if I'm Best Buy, I'm not going to turn around and sell that video game for $20. I'm going to make a profit off of it, so I have to mark up the price. And so that's what we're going to be looking at today. To make a profit, stores mark up the prices on items they sell. A sports store buys skateboards from a supplier for S dollars. What is the retail price for the skateboards that the manager buys for $35 and $56 after a 42% markup? First of all, we need to look at this. So when the original maker of the skateboard made this, they sold it to this company for a certain amount of dollars, and it was 100%. So, for instance, in that video game scenario, you sold it to me for $20, and I paid 100% of that price. I paid $20 of it. So you sold it to me for $20. I bought it for $20, so I paid 100% of the price. But now I'm going to turn around and I'm going to tack on some money here because I want to make some profit, right? And I'm going to tack on 42%. And I can do that by 42 times S. We learned that in the last problem. 42 times S. Well, 42%, so I'm tacking on 42%, which is my blue. So when I sell this skateboard, or in the video game situation, it is selling in my store now for 142% of the original price. So what we can do, and if I scroll down and look, I can take the cost of that item, which was $35, and multiply it times the 1.42, because 142% as a decimal would be 1.42. And it would give me the total cost of that item. You could do 42% of that item and then add it back to the original cost of the item. That's fine. Or you can do it as one step and figure it out. So let's look at another example of this. So let's look at the your turn. Rick buys remote control cars to resell. He applies a 10% markup. So we have a 10% markup. Write two expressions to represent. Well, we could say that he bought this car, plus he's going to do a 10% markup, because markup is a plus, 10% of the car. Or I could say this is 100%, this is 10%, so now I'm paying for 110%, which in decimal form is 1.10 of that car price. If Rick buys a remote control car for $28, what's his selling price? So we're going to do it the first way first. So the car was $28. The markup of it is 10% of the 28, which is 2.8. So I'm going to add that back to the regular cost, because that's how much profit I want to make off of this. And the remote control is going to now, car is now going to be $30.80. The other way to do it, which I'll do in another color, is, well, you paid for 100% of the car, plus you're paying for 10% of the car, so that's 110%. So I can do 28 times 1.1, because 110% as a decimal is 1.1, and 28 times 1.1, and again I get the $30.80. So either way works. Okay, so on the same page down a little bit, it says calculating markdowns. Markdowns are similar but a little bit different. So a discount store marks down all of its holiday merchandise by 20% of the regular selling price. So we're just going to stop there. So originally, if you would have bought this before the holidays, you would have been paying for 100% of it. You would have paid for the entire price of it. But now that it's being marked down is actually taking part of that price off. And you're taking off 20% of that price. So I'm taking off, cutting that part off, and it leaves me with 80%. And I get that because 100% minus the 20% is 80. So in the markup, we added the percent to 100%, but in the markdown, we're going to subtract it because it's a discount or a markdown. So if we continue looking at this problem, we had $16 decorations and $23 decorations. So I'm going to flip to the next page. So you can do 80%, because that 100% minus that 20 times the 16 and get 1280. And 80% times the 23 and get 1840. So let's do the your turn. A bicycle shop marks down each bicycle selling price B by 24%. Draw the bar. So I have this bicycle and it was 100%. I was going to pay for 100% of it. But then they decided, actually that's probably not the best place to write that. But then they decided to take off some of it. So that's what we're going to do. So we have 100%. And we're going to take off 24%. So I'm just going to guess about where 24% would be. That'd be 24%. So to find this out, I do 100% minus 24%, which is 76%. So now you're going to be paying for 76%. So what's the single term expression for this price? Is you're going to be paying 0.76 times the price of the bicycle. Now single, because it's all one term. Okay. So then if I want, let's say this bike was $100. I could find out the price by going 0.24 times 100. It's 24%. And get $24 and say, okay, well it was $100 and now I'm saving $24 off of it and finding out that it's $76. Or the second way I could do it is say, okay, I'm only paying for 76%, so I'm going to do 0.76 times 100, and it's going to tell me the 76 also. Now on the guided practice, I want to quickly look over one more example. Let's look at example 1. So she buys shirts from a clothing manufacturer for S dollars each, and then she sells them at a 35% markup. So that's going to be an addition. Write the markup as a decimal. So 0.35, 35% as a decimal. Write an expression for the price. Well, it's a markup, so I had 100% plus my 35%. So 135% as a decimal is 1.35. So I'm going to do 1.35 times the price of that shirt. How much is the retail price if it's 32? So I'm going to do 1.35 times 32. Oh, wrong button. And I find out that that shirt is now going to sell for $43.20. Now the next question is, how much was added to the original price? Well, if the price is now $43.20, and originally the price was $32, sorry, I would just subtract that and it would tell me how much my price changed. And my price changed $11.20. Sorry about that. And that would tell me how much it changed. All right, that was section 3.3.